All right, guys, here we go. Welcome back. Hopefully, you had a good spring break. Here's where we left off. We left off with section 11.2. So, as always, I'll call out the answers, check your work, and then go to Google, pause the video, go to Google Forms, put down how many you missed. So, here we go. One quick note: we get kind of lazy in as high school math teachers and high school books. We made a big point in fifth through I don't know eighth grade of always saying, hey, make sure you put the units always, and then all of a sudden we get to geometry and we kind of leave off units unless it's specifically. So meaning like if you were finding the area or the distance of something and they just had raw numbers, technically you're supposed to say units or units squared or volume units cubed, and then we get to geometry when we kind of get really lazy. So just be aware of that. If you ever get to a standardized test, just get into the habit of always putting units or units squared. Okay, and I will not follow my own advice because that's the way the high school math books work. Here we go. Question number 1, 29.9 square meters. Question number 2 is 6. Notice they don't say 6 units. They should say 6 units. Okay. Question 3 is 12. Question 4 is also 12. Question 5 is 16 root 3 square feet. Question 6 is 48. Question 7 is 40. Question 8 is 44. Question 9 is 84. Question 10 is 66. Question 11 is 16. Question 12 is 9 root 3. 9 root 3. Question 13 is 30 root 2. 30 root 2. Question 14 is 18 root 3 square centimeters. And question 15, it's an ugly one, 25 root 3 over 2. 25 root 3 over 2. All right, let's see. Then I gave you 27. There's two answers there. There's two triangles they want you to find the area. The area of ABC or triangle ABC is 40. And the area of triangle AMB is 20. And last, I gave you 32A through D. So 32A is 480. Question B is 240. Question C is 120. And question D is also 120. There we go. All right. All right, so here's what our future looks like. Let's see. We're going to have classes Monday, Wednesdays, and Fridays. So today is Wednesday. So a normal week would be Monday, Wednesday, and Friday. And then Tuesdays and Thursdays are for tutoring. So basically what we're doing is we're giving you 2 days to watch the videos, do your homework, and if you have any issues, that's when you're supposed to contact us. So I have Tuesdays and Thursdays devoted to, hey, I truly can't do question number 17. You send me an email, I'll help you through it. So don't get lazy. Sometimes we like, oh, that's a hard one. I'll just wait till he gives me the answer and explains it tomorrow, that sort of thing. So make sure you make ample use of that time for tutoring. If they ever relax I don't know, the rule or the dictate that says that we can't meet together, then we also wanted to possibly meet as small groups, but until they change that, we're not going to be able to do that. I also thought about doing some online video and that sort of stuff, and it's just really hard to have a camera showing on the board. We're still trying to work through the issue. We might still do something like that, but more to follow on that. Okay, so here's what the schedule looks like. We're going to do 11.3 today. 11.3 is pretty quick and easy class. Homework's a little bit challenging because I'm going to introduce one new thing at the very end. So it's not like the homework is quickly done, but it's also not that big. It's only one basic formula today. So giving you 2 days should be plenty of time to get it done. And then we'll just move on there. So it's going to be 3 weeks before we have a test. I didn't have a quiz. Typically, I would have a quiz here. I'm just going to see how the test goes first, and then we'll play it by ear if we reintroduce quizzes back. But we're certainly going to do at least a test. And obviously, the 800-pound gorilla in the room is, if we're going to do tests, it's going to be online of some sort. So I'm just going to ask you guys to, be great and good students that you are, and use the resources. Since it's open notes anyway for all my tests, but I'm just saying we're not going to use internet resources during tests, that sort of thing. And this goes for all your classes too. When you have to, we're in strange times right now. We need to be good human beings and need you guys to be good students and do what you're supposed to do. All right, enough of a speech. All right, here's your homework tonight. Pause the video if you need to. All right, so area of trapezoids. If you remember from pre-algebra, for those of you that actually took pre-algebra, if you remember from pre-algebra, this is the one weird area formula for the shapes that you're given. You know, people generally recall the triangle, the rectangle, the parallelogram even, but trapezoids, that doesn't get much love. It's the weird formula. One nice thing is I think on every single standardized test I've ever seen, they always list the formula for area of a trapezoid because it's forgettable. It's just one theorem today. I am going to show you, I know I said one formula. It really is just one formula. It's just two different versions. I'm going to show you two different versions of the area formula. All right, recall, trapezoid. We had trapezoids when we talked about quadrilaterals way back. I think it was chapter 5. So a trapezoid is a quadrilateral, 4 sides, where 2 of the sides are parallel. And the formula, or the definition says, or should say, exactly one pair of parallel sides. So there's the definition. Most math books that I've read typically use the word exactly one set of parallel sides. You got 2 sets of parallel sides, and it's a parallelogram. So when you only have one set of parallel sides, that makes it a trapezoid. Okay, so we've seen this thing before. We give names to the parts of a trapezoid. If you want to write this down, please do. We call the 2 parallel sides, we call them the bases. And yeah, generally when they draw trapezoids, the bases are the top and the bottom, but that's not always the case. I'll show you next slide a couple examples where that's not true. But what is true is that the parallel sides are the bases. All right, the perpendicular distance between the 2 bases, right, we call that the height. And lastly, the thing that you don't get in pre-algebra is we actually have names for the other 2 sides. So the other 2 sides, the 2 sides that are not parallel, anyone know? They are called the legs. All right, so we got legs of triangle, and we of a right triangle, and we have legs of a trapezoid as well too. So the 2 non-parallel sides are called the legs. So we got bases, and we got legs, and we got height. Those are the 3 names for the parts of a trapezoid. The height itself, remember, is the perpendicular distance between the 2 bases. So generally, you know, the trapezoids always look like this. And yes, generally we say base 1 is the bottom and base 2 is the top. But remember, if I turn it sideways, then that completely flips things around. So this is your, I don't know if there's a standard type of trapezoid or not, but these are your standard looking trapezoids. But there are 2 different offshoots of this as well too. So there's 3 total flavors. There's your general trapezoid, those 2 that I show right there, and then we have this one. This is where one of the corners is a right, and ends up when we show this in chapter 5 that if one is a right, then the opposite side, because remember parallel sides. So you could either say alternate interior or same side interior or supplementary. So even though they're only going to show one as being a right angle, you actually get 2 right angles there. So this one's called a right trapezoid. So the height would be one of the sides that's attached to the little tiny square you see right there. And the third flavor is called an isosceles one. That's where the 2 legs are congruent. Okay, we like isosceles trapezoid. In fact, I would say isosceles trapezoids are probably the most common that you see in everyday life. If you ever think about an arch made of bricks or something like that, then it's called the capstone or the middle stone is always an isosceles trapezoid. Okay. Another quick note, even though that we call the bottom base 1 and the top base 2, if it's looking like this, I mean, there's no reason for the bottom being base 1 and then the top being base 2. It could be the other way around, right? So for instance, if I wanted to flip it completely around, then the short side is the base 1, base 2. And then also, like I said, the bottom could be base 2 and the top be base 1. It doesn't make a difference. And then lastly, we generally don't write the word base. It's just too much. You know, we're efficient as mathematicians, or lazy, as I like to say. So generally we say, I mean, this is how you typically will see it. You'll see a lowercase b with a subnotation 1 and 2. Make sense? Okay, did anybody actually remember the formula for area of a trapezoid? I would bet that there's probably one person out of all of you that could remember it, because it's not too memorable. All right, but for those of you that did remember it, there's the, and we're about to prove it here. There's the formula. Let's write this one down. This is Theorem 11.5, and it basically says that if you have a trapezoid, that its area is equal to the sum of its bases times the height divided by 2. Now, this is the general formula that you'll see in every single math book and every single standardized test, and nobody uses it. Most people use this one because, generally this is on a calculator section. It's just easier to do it this way. Some people will argue that, well, with a graphing calculator, you just do 0.5 times h times open parentheses, base 1 plus base 2. I agree with that as well, too. But if you had a good pre-algebra teacher, then you probably remember doing the second formula a lot, too. Okay. All right. I said today's a quick class because we're really just doing 2 basic examples from this. Let's go back to 8th grade or 7th grade when you first learned this formula, and let's do an 8th grade example. And this is, I think, example 1 in the book. So they basically give you a picture. Do they? No, actually, they don't give you a picture. They just give you in word form. But I gave you a picture. All right, Merry Christmas. So there's a picture. I've got a trapezoid because it says it's a trapezoid. The 2 bases are 8 and 12, and the height is 7, and it says what's the area. So this one's pretty simple, just a plug and chug. The height is 7, the 2 bases. Following PEMDAS, 8 plus 12 is 20. Let's see, 20 divided by 2 is 10. 10 times 7 is 70. So we get 70 square units. All right. And if you remember in pre-algebra and in pre-algebra, you did bunches and loads of these. Sometimes you solve for the height and whatnot. Well, in geometry, they're going to make your life a lot more challenging. There might be special right triangles involved. There might be, have to use the Pythagorean theorem to get some values. Basically, they're just going to not going to. I think the first couple of examples are pretty easy, but after that, then they make your life a little bit more challenging. So here's just one example of it. All right, so it says find the area of an isosceles trapezoid with bases of 6 and 10 and legs of 5. All right, notice what we're missing here. Yeah, we're missing the height. So there's just a general picture. You can freehand this one pretty quickly. So notice in order to calculate the area, we need the height, and the height isn't listed right here. So for those of you that want to challenge, pause the video, see if you can get through this one. If not, wait till I give you a hint and then take it from there. All right, let's see how this one's done. I need the height. Well, when you look at the picture, I guess one thing that stands out is that we have a right triangle, correct? Well, I know that's the basic. I'm going to use the preferred formula. I know that's the formula. I got my 2 bases. I don't have the height. So first thing, I got to find the height. So here's how this one is done. It may not be obvious, I mean, if we could use the Pythagorean theorem, we could, find that if it was a special right triangle, right, or even if we could use some trig as well, too, if we knew any of those angles. Well, the only angle we know is 90 degrees. So that didn't help us well. So maybe the Pythagorean theorem will help us out. Well, I only know one side of the 3. I need at least 2 sides of that triangle, right? So here's how this one is done. Remember that the 2 sides are 2 bases are parallel to each other, so that means any distance along those 2 parallel sides would be listed as a height. So if I go from the 2 vertices of the trapezoid, the 2 top ones, right, and I draw the height, which I did right there. Notice what shape did I make in the middle? Yeah, I made a rectangle. So what I need is that part right there and that part right there. If I knew those 2 parts, right, then I would be able to solve for the height using Pythagorean theorem. So the question is, well, how big is x? And the key here is, you can pause the video so you can take it from here. The key here is recognizing that the middle is a rectangle. Can you see that? Right, we have 2 right angles right there because they're heights. Well, we know that the 2 sides are parallel, so that means the opposite angles are also right. So you got 4 right angles. You got a rectangle. Now on that rectangle, that means that one side is 6, the top is 6. That means the bottom is 6. And if the bottom is 6, then that leaves 4 left over because the whole thing is listed as 10. Rewind the video if you need to hear that again. So we know that the top is 6. That means the bottom part of the rectangle is also 6. Therefore, that leaves 4 left over. Well, if those two pieces of the triangle right there are x, all right, if they are x, let me back up a step. Why do I know that they're both x? Well, I can do that pretty simple. You see the two triangles? Yeah, well, we know that the hypotenuse is 5. We know that the long leg right there is the height of the parallelogram. And since the height is equal, then by hypotenuse leg, those two triangles are congruent. Therefore, the bottom parts are congruent. I should have said that first. Okay, so going back, we know the top is 6 of the rectangle. The bottom is 6, which leaves 4. That means x and x are the values 2. Now this only works, that logic only works because it's an isosceles trapezoid. If it was not an isosceles trapezoid, this particular problem couldn't be solved in this fashion. We would need something else. Maybe you need some angles, special right triangles, or any of those angles, and we could use some trig functions in order to solve that, sine, cosine, tangent, that sort of thing. All right, but when it's an isosceles trapezoid, this is the technique. If you know both of the bases, then the individual pieces parts at the bottom right there are equal to or congruent to each other. Okay, so 2 and 2. Why did we do that? Because remember, we're trying to find the height. So we can just now, because of the right triangle, we can just use the Pythagorean theorem. So the height, right, would be the long leg. The 2 would be the short leg. So let's see, 2 squared plus h squared equals 5 squared. So that's 4 and 25, subtract 4, and then take the square root of both sides. Okay, and remember we're in geometry land, so h is not plus or minus, it's just positive. Okay. Right, now where are we? Oh yeah, we're originally trying to find the area of the sucker. All right, so now we know the height is the square root of 21, so we got everything we need to plug into the formula. We got the height, we got the two bases. The two bases are 6 and 10. The height we just found out was root 21. 6 plus 10 is 16. 16 divided by 2 is 8, so 8 root 21. Okay, square units. Hey, look, I'm not lazy. All right, so there was a geometry exam. I'm not saying everyone tonight is like that one, but there are a few that are like that. So if you get stuck, don't hesitate, send me an email. I'm going to try to make all my responses to any email be very quickly so that this is a doable process that you want to use. Okay. All right, so there's your one geometry example. Tonight for homework, there's going to be a table. You'll kind of see, sometimes they give you individual pieces, parts to it. Other times they give you some values that you might have to use a different formula for. And there's going to be a word there for those of you. I know Caitlin's probably already started on her homework. And when you get to question number 1, you get to this one thing about a median. And most of you have probably forgotten what a median is. So these are going to be some more geometry trapezoids. Recall from chapter 5 that the definition of a median was you take the midpoint of the two legs of a trapezoid and connect them. And that, in this case, MN, is what we define as a median. And Theorem 519 says two things. Well, it says that MN, the median, MN is parallel to the two bases. And then also we get a formula from it. The formula says that the length of MN, or the length of the median, is equal to the sum of the two bases divided by 2. In other words, the average of the two bases. Okay, so instead of saying MN, I'm going to use the word median, right? So median is equal to base 1 plus base 2 divided by 2, and that kind of looks familiar. Right? We didn't talk about this in chapter 5, but now we will. So the median of any trapezoid is equal to the sum of the two bases divided by 2. Okay? So if we go back to the formula that we were just given, look at the second part of that, or the second formula there in yellow. It says base 1 plus base 2 divided by 2. And we just said that that is the median. Right? Therefore, we get a third formula. Technically, it's just the second, right? The first two in yellow are the same formula. So we get a second formula, which is this. The area of the trapezoid is also equal to the height times the median. Now, how often are they going to give you the median? Well, they're going to give it to you tonight for sure, but occasionally you might have the median. And when you have the median, you don't need to do anything more complicated than just multiply it by the height and you're done. Okay, so don't cheer and say, wow, look how much easier that formula is, because how often are they going to give you the median? And the answer is not very often. But when they do, then you got a secondary formula that you can use. Now, I will just say this. Notice it's the same formula. right? The median is base 1 plus base 2 divided by 2. So it's not like it's truly a different formula. We're just substituting the word median in for base 1 plus base 2 divided by 2. But interestingly enough, in the formula for area of a trapezoid is the definition of a median. Okay, so anytime that you're calculating the area of a trapezoid, inside that formula is the distance of the median. All right. So here's one, I'm going to give you two of these. Here's one like tonight for homework. It'll say, what's the median of a trapezoid whose area is 300 and whose height is 10? This is one of the problems tonight for homework. All right, so well, let's see. What do we got? We got area and we got height. So we have two formulas now. We have the original formula and we have the median formula. It's not really the median formula, but they're both area of trapezoid formulas. So the particular one that we're going to use is this one right here. When I know the area and I know the height and I'm trying to calculate the median, then the easiest way to do it is use this formula right here. So I know the area is 300, I know the height is 10, and then it turns into a one-step equation. It's pretty simple, right? Make sense? All right, so the question will be, which formula do I want to use? The area is equal to 1/2 times the height times base 1 plus base 2? Or do I use this one? And the answer is, well, when in doubt, plug it into both formulas and see which one only has one variable. And the one that only has one variable is the one that you're going to use to solve the equation. Or you can just read it carefully and figure it out just from the context of the problem itself. So this was the more easier of the two. Let's do, I wouldn't say that even this one's that much more challenging, but let's do one that's a slightly more challenging. All right, it says, what is the height and the median of a trapezoid whose bases are 27 and 9 and whose area is 90 square inches? Okay, so usually when they give you something that's complicated like this, you just basically pull out everything you got about trapezoids. We got two basic formulas. We have the standard one and we have the one for median. So let's just plug in the numbers for the standard one and let's see if it makes any price. If not, then we'll use the other one. So it says the two bases are, let's see, 27 and 9, okay. And it says the area is 90. Okay, when I do that, notice I only have one variable in the formula now, h, and I can clearly solve for that, okay? So let's see, let's solve for h. 27 and 9 is 36. 36 divided by 2 is 18. And 90 divided by 18, I think it's divisible. That would be a height of 5. And this was in inches, so inches. Okay. So first part of the problem done, we found the height. Now to find the median, well, there's two ways of doing it. Remember, it's defined as base 1 plus base 2 divided by 2, or we have this formula right here. Either one will be fine. For those of you on the ball, I would say the second one is, I'll show you here at the end, is a little bit easier to manage if you've already done the first one, the one on the left there. All right, let's see. Area of trapezoids, 90. We don't have, oh no, we just figured out the height. The height was 5, so therefore, one-step equation, we're at 18. And for those of you that were on the ball, remember the median was defined as base 1 plus base 2 divided by 2. And look at the on the left side, well, we already did that. That was 27 plus 9 divided by 2. 27 plus 9 divided by 2 was 18. So in either way, whichever one of those you wanted to use, you still got to the same answer, which was 18 inches. Okay, so I think I gave you some good examples there of what the homework will look like. Remember, it's going to be this big Mongasso table thing that you just basically plug in numbers. Right on this screen right here are the three formulas that you would use, okay? The three formulas that you would use. And then you plug your numbers in, and whichever one only has one variable left is the one that you're going to use to solve. So hopefully that helps you for table number, or for the, I think this is questions. I'm flipping the book here real quick. Yeah, questions 1 through 8. Some of the numbers are very nice. Some of the numbers are not very nice. For the ones that have fractions, I would just convert everything to an improper fraction and then multiply or divide away for those. Okay. So we really only did one theorem today, 11.5, which is the area of a trapezoid. Well, here's your homework. As always, send me an email, pause the video, rewind as necessary. And with that, I'll conclude the class, and I'll see you guys on Friday.